This video, we're going to talk about 2.6 Objective 3, where we solve applications involving the volumes and surface areas of solid figures. Haven't used this setup in a little bit, but we're going to have some problems that require a lot of extra work. So I've got the whiteboard here to work out the problems. You can see the problems up top here, and you'll see what I'm doing on my scientific calculator on the side. Let's go ahead and get started. City sewer pipe has a diameter, D, 5.0 feet, and a length that's going to be equivalent to the height because in the formula, because the pipe is laying on its side, the cylinder is going to be 450 feet. So our formula is going to be V equals pi r squared, and we'll say L, where r is 2.5 feet. So V is going to be pi times 2.5 feet squared times 450 feet. It's going to give me an answer in cubic feet. And they want us to use the appropriate number of significant digits. So we're going to use 2 significant digits here. This is going to be pi times 2.5 squared times 450. It's going to be 8,800 cubic feet. The reason I use 2 significant digits is because this is 2 significant digits, and that's 3 significant digits, and I go with the smaller number of significant digits. All right. Pole supporting a wind turbine is see if I can get this to the best of my ability. It's kind of like this. There you go, like that. It's constructed of solid steel in the shape of a frustum of a cone. That's this, and it measures with a height of 57.2 meters, a diameter of the pole at the bottom of 4.40 meters. That means my big radius at the bottom is 2.20 meters. And my little radius at the top is going to be 1.10 meters. What is the volume of the pole? And that's the correct formula there. That volume is 1/3 pi h times big R squared plus big R times little r plus little r squared. So volume is going to be 1/3 pi, and then h is 57.2 meters times, and then this is 2.20 meters squared plus, just go ahead and do this in the calculator. We have 1/3 times pi times h is 57.2 times big R squared plus big R times little r plus little r squared, close parentheses. My volume is equal to 7.35045584. We're told to round to the nearest integer is needed. So I get 507. And this is volume, so this is going to be in cubic meters. Let's look at the next problem. One of the ancient stone pyramids in Egypt has a square base. This square base that measures 144 meters on each side. The height is 90 meters. What is the volume of the pyramid? The 1/3 times the area of the base times the height. So that's going to be 622080. We're not told to round at all, so we won't. Building is a sphere with a diameter of 131 feet. Let's just change that into a radius right now because I know that's what I'm going to need for the formula. 65.5 feet. The volume formula for a sphere is 4/3 pi r cubed. So this is going to be 4/3 pi times 65.5 feet cubed. 4/3 pi r cubed. And we're told to use an appropriate number of significant digits. And so that's going to be 3 significant digits. One 1,180,000 cubic feet. The next problem says this propane tank has the shape of a cylinder with a hemisphere at each end as shown. So it looks like a capsule. Find the volume of the tank. Note that the figure is not to scale. So volume of the tank is going to be these two hemispheres added together will be a sphere. This cylinder piece is going to be R is going to be 6.50 divided by 2. It's going to be 3.25. And H is going to be 6.00. We're going to use 3 significant figures here for everything. And pi times 3.25 squared times 6.00 plus 4/3 times pi times 3.25 cubed is 342.8917482. 3 significant figures is going to be about 343 cubic feet. Special wedge is in the shape of a regular pyramid. This with a square base. This is 12.0, 12.0. So the area of the base is 12.0 squared is 144 square millimeters. And that's going to be 3 significant figures there already. The height is 60.0 millimeters. And I need the surface area, the lateral surface area, which is 1/2 PS. P is the perimeter of the base, which is 4 times 12.0 is 48.0. This is millimeters. And S we're going to find using the Pythagorean theorem that if I give a point here right in the center, that's 0.0, it's going to come up to a point here that is at the top and a point over here. I'm just going to call this point A and this point up here B. Don't worry about this. This is the area of the base. That doesn't have to do with AOB here. And this side here that's dashed is going to be my height. And this slanted side here, my slant height here, S, I'm going to find with the Pythagorean theorem, knowing that this distance here is half of this side, so that's 6. My height was 60.0, and this is 6.0, but I'm going to call that 6.00, so it's 3 significant figures, just like my sides were. So I'm going to have 6.00 squared plus 60.0 squared is equal to S squared. 6 squared plus 60 squared. I'm just going to put it inside the square root sign and solve for S. 6 squared plus 60 squared. Square root that. S is going to be about 60.3 millimeters. And so that makes capital S equal to 1/2 of my perimeter is 48.0 millimeters times 60.3 millimeters, 5 times 48 times 60.3, and we're going to round to the nearest 10, is going to be this plus this is going to be area, total surface area is about 1590 square millimeters. Let's fill that in. A is 1590. I want to use the letter A for that. All right. That was probably the hardest problem in the set. And one more problem here. A smart speaker is a cylinder with a height of 5.5 inches, a diameter of 3.3 inches. 3.3 divided by 2 means R is 1.65 inches. Find the volume and use the appropriate number of significant digits. So V is going to be pi R squared H pi. It's 1.65 squared times 5.5. We're going to use two significant digits here because everything started off in two significant digits. Volume is about 47 cubic inches. And that's it for this video. We'll come back next time and we'll talk about 2 point, just a second. We'll be talking about 3.1 objective 1 next time. So thank you again. See you next time for the next video.